Sensors. The basics of signal processing and machine learning. We are going to focus on different types of sensors that can be used in industry. What different types of data sensors could be used in the monitoring of manufacturing processes. Sensor is a device that detects or measures a physical property in records, indicates or otherwise responds to it. Few examples of social are acoustic sensors, thermal sensors, magnetic sensors, and optical sensors. Acoustic sensor converts sound into an electrical signal. Examples of this class of sensors are microphones. In microphone, sound is first converted to mechanical motion by means of a diaphragm. The motion of pitch is then converted into an electrical signal. Microphones are extensively used in telephone, hearing aid, and concert halls. In manufacturing applications, acoustic sensors like microphones could be used to monitor the machine performance. The recording from microphones could be used to detect tool wear. Thermal sensors are used for measuring temperature or difference in temperature. An example of this class of sensor is thermometer. Thermometers can be used to measure temperature or temperature difference, and they are used widely in industrial and medical applications. In industry, the temperature of a cutting tool is continuously monitored by thermosensors like thermocouple. This helps to regulate coolant flow. Magnetic sensors are used for sensing magnetic fields. Generally, they use electric voltage for detecting magnetic field. An example of this category of sensor is microelectromechanical, or MEMS, magnetic field sensors. It is a small-scale MEMS device for detecting and measuring magnetic fields. These sensors can also be used for sensing corrosion on a part. Optical sensors are used for sensing light. Photodetector is an example of optical sensor. A photodetector converts light signals that hit the junction into voltage or current. Used extensively in TV manufacturing. In manufacturing application, optical sensors are generally used for inspecting the quality of the finished product. Sensors and machining centers are helpful, so we want to have our machines know where the parts are in the machines. So they'll have to touch off the part. They'll have to know where a part is in space. Sometimes they'll be touching off on fixtures or the part themselves to know where that is, so those sensors are important. Another place that sensors are used to detect broken tools. Before a machine program runs, we want to make sure that we're not going to be making scrap parts when the machine may be making hundreds or even thousands of parts. So that the sensor will check to make sure that the tool is present and not broken before the machine will even run. That sensor communicates back to the machine and kind of qualifies the run for us. Signal processing. Before understanding the concept of signal processing, let's first try to understand the meaning of the term signal in the intelligent machining domain. Signals describe how some physical quantity such as temperature, sound, etc. varies over time and our space. For example, consider network of your smartphone. The phone has a set of bars displayed on the screen to indicate how strong your network connection is at a given time and place. If 5 bars are full, your network connection is strong. When it drops to 2 bars, you should expect a weaker connection. Here, the signal we reference describes the strength of the phone network. Signal can be represented in various forms, such as bars, waves, and curves. As discussed in the previous lesson, different types of sensors can be used to monitor the wear of cutting tool and the temperature of machining tool tip or workpiece. Sensors collect information in different forms, such as sound and light, etc. This information may not be in the form we understand or may contain noise. For example, a sensor may be monitoring sound from a machining center. The oral sound recorded by the microphone sensors may contain voices of operators. All sounds by nearby machines in the manufacturing shop. The additional source of noise leads to errors in signals. Consequently, the initial signal, that is the sound, should be cleaned up to remove the noise. Once the noise is removed from the original recorder signal, the cleaned, noise-free signal can be used for pattern checking by comparing the current noise-free signals with previous recorded signal datasets. First, signal processing includes all those activities that needs to take place to convert the signal collected and the source into information that could be used to make decisions. This could include cleaning up of the initially gathered signal to remove noise, and analyzing the data to generate actionable information.